Okay. Hello, this is the Lab 2 ANSYS tutorial for aerospace experiments. My name is Eli. This is for Lab Group 5. Okay, to get started, we are going to open up a new fluid flow project, right-click on geometry, and press New Design Model or Geometry. Now, once that loads in, it'll be a couple seconds. We are going to orient on the XY plane and begin sketching 4 lines connected to each other along the x-axis. Make sure the endpoints are touching. And once you have your 4 lines, you can begin dimensioning them. Hit dimensions and horizontal, and then click on each endpoint. Okay, now we're going to enter the values that you recorded or measured from the lab. This is what we got for ours. Okay. Now once that is done, we are going to constrain this to the midpoint of the origin, or the midpoint of the line to the origin, by drawing a line from endpoint to endpoint, and then constraining that midpoint, and then clicking on the origin. Okay, now that is good. We are going to draw our vertical lines now along the endpoints that I mentioned a second ago. The height doesn't matter yet. We'll adjust that. And we're going to leave one off in the last point. We don't need one there. Okay, now we're going to vertically dimension these. And these will be the heights along the wind tunnel that you measured. Should be 22 across the first two, and then 6 across the next two. That's where the road or the test section begins. And now we're going to constrain these with a midpoint so that they are equally spaced along this line. That should be good. Now we have to draw our diffusing section lines. Start right there. Constrain that with a midpoint just to be safe here. And now we are going to draw the lines and then put in our half angle values. Okay, we are going to go to dimensions and angle. Might take a couple of tries to get the angle that you really want. There we go. That should be 183, 180 plus the 3 degrees. We measured for a half angle here. Let's do the next one. That one's easy. That one will just be 3 degrees. Okay, that should be it. Now we are going to trace the outside of our other lines and have them all connect. Okay, that should be good. We're going to now trim our excess lines that we don't need anymore. Okay, and that is what your sketch should look like at this point. And that should be about it for the sketch. All we have to do now is get up here and do surfaces from sketches. If you just expand this, you can select sketch one here. Select that, hit apply. And then we're going to hit generate, and then should fill in the inside, shade it in a little bit, and that is it for the design modeler. We are good to exit out here of the design modeler. And now we're going to edit the mesh. So right click on the mesh and go and hit edit. It's going to take a few seconds to load in. Okay, once that's loaded, orient it on the XY plane again, and it should look like this. And we are going to select mesh here. We are going to click on method up top here. And it's asking us for a body, so we're just going to click on this body, hit apply. And we are going to change the method from quadrilateral to triangles. And then we're going to hit generate. And there you can see the triangles, but they are a little too big for us. So we are going to hit mesh. Change the element size. For simplicity's sake, since it doesn't matter for the simulations right now, we're going to do 0.015, but in the real simulations, I ran 0.005 element size. That's okay, we're not going to care about that. And then we're going to hit generate here again. Give that a second to mesh. You'll see the bottom corner, it's loading 5%. The smaller your triangles, the longer it will take to generate the mesh. So keep that in mind, as you can see. Well, it's never taken this long, so I'm not sure what the issue here is, but can't change that. Nope. Okay, we're locked in pretty much now. Okay, I think something is wrong here. Let's just stop the mesh if we can. For the sake of getting this video on the road, we're just going to hit 0.25. That's not ideal, but gonna have to make it work for right now. Okay, that one worked. Now that is over with, we are going to oh, here we go. We're gonna hit edge selector up here at the top and begin naming our edges. So we are going to click on them once, left click on them, hit enter on our keyboard, and name them what we want. This one is going to be, the left edge is going to be velocity inlet. Hit OK. Click on the right edge and do the same thing, hit N. This one's going to be pressure outlet though. Again, hit OK. And now for the rest of the walls, we are going to click, hold, control, and click on all the other edges besides the two that we've already named. Again, hit N, and these are going to be called walls. And hit OK. And you can see, double check that these are all named correctly. This one is not. You can just rename it though. At the Y and cool, good to go. And that should be it. We are good to exit out of the measure. Okay. Once that closes, we're going to have to update the measure, update the project to reflect the new mesh we just made. So right click on the mesh and hit update and give that a second. It should turn a green check mark like the geometry one above it. Okay, that is good to go. Now we're going to go to setup after this. Right click and hit edit setup. Okay, we're going to make sure it's in 2D. We're going to select double precision. Make sure that display mesh after reading is checked as well, and then hit start. Give it a second to fully load in, and we're going to just forget about that message. Okay, so the first thing we are going to do after you kind of see what's going on is over on the left, boundary conditions, expand the inlet, double click, and we are going to change the velocity to reflect what it should be for the 30 hertz frequency value. Can really be whatever you guys record, but what we ended up getting for our 30 hertz value at the inlet is about 1.93 meters per second. You're going to hit apply. We're going to hit close. Okay, now we are going to go over to models right above that. Right click on energy and make sure it's turned on. Right click on viscous right beneath it. Hit edit. We're going to switch it from K omega to K epsilon. And we are going to turn on enhanced wall treatments. Hit OK. Okay, now we are going to scroll down and hit initialization and hit initialize on hybrid initialization, which should be the default selected one. And once that initializes, it'll say convergence not reached. That's fine. We're going to go then to run calculation. This can kind of be whatever. We're going to hit 150 just to make sure that it has enough iterations. And then we are going to hit calculate. And it will take a second over here. You'll see it kind of running through each iteration now. Should take about 50 iterations to converge. Okay, once that is complete, we can go down to graphics, double click on contours. And we are just going to name this velocity 30 hertz. We're going to change this to velocity. We're going to select all of these, and we are going to hit save/display. And we're going to close this. You can kind of see it does make sense. The velocity goes from very, very slow, slowly speeds up, and then rapidly gets to its maximum here at the throat, where it then begins to decrease afterwards. That checks out, that makes sense. So simulation should be pretty accurate. Now we can also go to XY plot. We can name this one velocity centered line 30 hertz. Changes to velocity. But as we said, we want this along the central line. So we're going to create a new surface, a line rake. And we are going to put in the endpoints of the inlet and the endpoint of the outlet. Which if you align your sketch along the origin, they should be equidistant. For us, it came out to about negative 1.18, and then positive 1.18. And then we're going to hit create and close. We're going to select that. You can rename it, but I just use it as line 4. And we're going to hit save plot. That is not correct. Let's making a new line again. Sorry for the technical difficulties here. Look at line 5. That's not doing it either. Share contours out of here and make sure those are all good. Hmm. Well, I must have done something wrong. However, one point meters per second. Yep, that is good. Let's initialize this. Still just gonna run the simulation again. Calculate that. I'm pretty sure I figured out what we did wrong now. I can try to go fix it if this doesn't work here. I'm just gonna create a new surface again. Meters negative 1.18. Well, let's try this way. Everything, I think I forgot to change the units into inches when I was making the sketch. So let's just see if this might work. Using inches here instead of meters to properly convert. All right, close that, select center line, unselect that one. Change this to velocity and name this to velocity, please work 30 Hertz. Save plot. There we go. Okay, so if you had in the sketch change your units to inches, then the previous value of 1.18 would have been correct. But since by default the sketch is in meters, I had to use the inches value. It's going to be about the same values for velocity and for whatever else. Okay, if that looks more like it, see velocity exponentially increases faster and faster up until it gets to the throat where its maximum is about 7 meters per second. That checks out. Okay, we are going to now uh, see what the static pressure looks like just for the sample. Save plot. That checks out. Should be the opposite of velocity, reaching its minimum at the throat because velocity is at its maximum. Velocity is at the maximum at its throat. Okay, so those are good. We're going to close that. You can re-access those here. You can also, if you wanted to, create a new one. We're going to do this one as let's do dynamic pressure here. We're going to hit right to file. So before we do that, we're going to make sure it looks right. That looks pretty good there. So now we're going to hit right to file. And if you hit right to file, you are able to name it. We're going to name this one dynamic pressure, center line, 30 Hertz. Hit OK. And then that will show up in your files wherever it was saved. There, we'll try that again. Right. I'm just gonna do DP. Oops. We're gonna change the folder first. Put it in ANSYS 3810, which is class here, lab 2. We're gonna do DP CL 30 for simplicity. Okay, that is saved. Now we're going to go to our files. On lab 2. And there it is, DPCO30. There's all your XY values. You can then export that into Excel and create your graphs, but that is not ANSYS, so that is not part of this tutorial. But yeah, that about pretty much wraps it up. You do the same thing as you did for velocity contours you can do it for pressure, static pressure, select all the, oops, don't select those. Hit save and display there. Checks out. Static pressure is higher when there's less movement. Okay. Yeah, that about covers it. Thanks for joining us.